Slide 68. I'm going to show you how to solve a system that has infinite solutions. So hopefully you find this beneficial and helpful. We are going to use the Gaussian method again just to get us more practice in that Gaussian method. So here we go. The first thing we're going to do is we look at equation 1, and hey, it's good to go. Has a 1x. And so equation 1 is going to stay the same. X minus y plus 5z equals -2. That's equation 1. It stays the same. To get equation 2, we need to eliminate the x. Okay? Now, you could use equation 1, equation 2, and multiply equation 1 by something, but if I'm eliminating the x, really, couldn't I just take equation 2 plus equation 3, and it would, or subtract, sorry, if I subtract equation 2 and equation 3, then they would cancel out. So I'm going to take equation 2 minus equation 3. That's going to become my new equation 2. So I get 2x plus y plus 4z equals 2. And I'm going to subtract 2x plus 4y minus 2z equals 8. Now these will cancel. Y minus 4y is a -3y. 4z minus a -2z is a plus 6z. Be careful when you're adding and subtracting. 2 minus 8 is a -6. Again, remember you're subtracting every single one of these. If you need to, distribute the negative in and then combine like terms, or 2x minus 2x cancels. Y minus 4y is -3y. 4z minus a -2z is a plus 6z. 2 minus 8 is -6. This now is equation 2, and we are so close to having equation 2 ready. We just need to get rid of this -3. So what do? We need to divide by -3. Or, like I said, instead of dividing by -3, we're going to multiply by -1/3. So I'm going to take -1/3 times that by equation 2. It's going to become my new equation 2. So I get -1/3 times -3y plus 6z. Oops. Equaling -6, and it's got to be multiplied to every single term in there. So that's going to give us -1/3 times -3 is going to be positive y. -1/3 times 6 is a -2z. -1/3 times a -6 is a positive 2. So there's equation 2. That's now my equation 2. Y minus 2z equals 2. Hey. Looking good so far. Now for equation 3. We need to take this equation here. We need to eliminate the x's. Then we need to eliminate the y's. Okay? So, to eliminate the x's, we could say, okay, we still can take this equation 2 here, the original equation 2, and we can take equation 3. So let's take equation 3 and subtract equation 2, and that's going to become our new equation 3. So the old equation 2, the original equation 2, and the old equation 3 is what we're using here. It's going to become our new equation 3. So I get 2x plus 4y minus 2z equals 8, and I get 2x plus y plus 4z equals 2, and I'm going to subtract that bottom one. I put parentheses around it to remind me I'm subtracting the whole thing, okay? So 2x minus 2x cancels. 4y minus y is 3y. -2z minus 4z is a -6z. 8 minus 2 is 6. I want this now, I want to eliminate the y. So if I were to take and multiply this new equation 2 here, if I take the new equation 2, multiply it by -3, so if I take -3 times my new equation 2, and then add that to my new equation 3, then I would eliminate the y's. So I get, so this negative 3 times equation 2, negative 3 times all of this would be negative 3y, negative 3 times negative 2 plus 6z equals negative 3 times negative 2 is negative 6. Then I have my new equation 3, which is 3y minus 6z equals 6. And I'm going to add those together. These are going to cancel. These are going to cancel. Oh, I get 0 equals 0. Okay, remember 0 equals 0 is an infinite amount of solutions. The only stipulation here, it is true that there are infinite solutions here, but the only stipulation is that whatever we're going to put in for z, like we can put whatever we want in for z. So let's say that we put any number, call it t, because we don't know exactly what number we're going to use. It's just any number I want. Z can be any number I want it to be. The only thing now is that once z is t, y is bound. Because if I plug t in, I get y minus 2t equals 2. So that would be add over the 2t. So y is going to be 2t plus 2. So y is 2t plus 2. Again, z can be anything because when we try to get z to figure out what it was, we got 0 equals 0, which is an infinite amount of solutions. So t can be an infinite, or z can be an infinite amount of solutions, whatever I want it to be. So I just let it be a variable t because it could be anything. But then y is bound. Once I pick a variable or value for t, then y will have to be 2t plus 2. Now I can back substitute what y and z are into here. So I get x minus 2t plus 2 plus 5 times t equals negative 2. So distribute the negative here in. Gives us x minus 2t minus 2 plus 5t equals negative 2. A negative 2t and a 5t make 3t. So I get x plus 3t minus 2 equals negative 2. Add over the 2. That's going to be 0. So x plus 3t equals 0. Subtract 3t. And I get x equals negative 3t. So, again, t can be anything I want it to be, but y and x will be bound to whatever t is, and you can find them by just putting in. So if I said t is 4, well, that's cool. That means y would have to be 2 times 4, which is 8, plus 2, which is 10, and then x would have to be negative 3 times 4, which is negative 12. So that is a solution. What if I said t was, I don't know, 1? Okay, then this would be 2 times 1, which is 2, plus 2, which is 4, and negative 3 times 1, which is negative 3. That's also a solution. There's infinite solutions we can choose, but t will dictate what x and y end up being. All right, we're done. Hey, hopefully that helps. If you guys have questions or concerns, I'll have some office hours. Let you know about. Have a great day. We'll see you later. $10.50.